Oke, terima kasih kepada PT Total Entero Solusindo dan Sormen. Mr. Bill, are you ready to give the presentation?
Yes, thank you very much.
Okay, please, time is yours.
Okay, I'm going to share my screen here in a second. Okay, hello. Once again, my name is Bill Freed. I am with the Sauermann Group. My role within the company is a few roles. Most importantly, I am a product manager within the group, specializing in IAQ instruments and also combustion gas and emissions analyzers. And I'm also the marketing director in the Americas. I'm based on the East Coast of the United States. It's a little bit different time of day for me right now, but I'm very glad to be here. My background is I was originally with E Instruments from 2006, and then in 2018, Sauermann acquired E Instruments, and then I remained with the company just now under the Sauermann name. So if we look at, I'm going to just start with a little bit of history of Sauermann. So once again, the company was started in 1976. Sauermann started as a pump company, which is something we still do. That's in a lot of parts of the world, that's especially in Europe, that's what we're very well known for, is condensate pumps for pumping out the water and condensate from air conditioning units, also some heating units. So that's traditionally what Sauermann's known for. And then as the company progressed, we started building up more of an international presence with having many more locations. So right now, Sauermann, the corporate office is based in Belgium. We have 4 factories worldwide. The 2 largest factories are both in France. Then we also have an instrument factory in the United States, and then also another factory in China. But the majority of our products, especially the ones we'll be talking about today for IAQ applications, are manufactured in our southern France location. So a few key parts of the progression of the company, as you can see from the timeline below, is when Sauermann moved from strictly being a pump business to being an instrument business also. So that started with the merger with a French company called Chemo that started in 2015 and then became fully official in 2020. So a lot of the products we're going to talk about today actually still have the Chemo branding, even though, once again, we're all part of the Sauermann Group. And then the other important acquisition was in 2018. the E-Instruments group was acquired by Sauermann. Once again, E-Instruments was an instrument company specializing in IAQ instruments and then also combustion gas and emissions analyzers. So right now, in addition to the 4 factories for Sauermann, Sauermann also has sales and administrative offices in China, Australia, United States, UK, Germany, Spain, Italy, and I believe I hit them all. So once again, Sauermann started mostly as a European-focused company, but has now reached out to all parts of the world. So in addition to the IAQ instruments, which will be the focus of what I'm presenting today, once again, Sauermann does offer many other products and services. Like I said, traditionally, it's been the condensate pumps. There's also other instruments. Combustion gas and emissions analyzers for measuring hot exhaust gases coming from combustion equipment, such as boilers, furnaces, kilns, heaters. We also have a set of HVAC instruments, such as simple manometers, thermometers, thermal hygrometers, a hot wire probe to measure airflow. Those are all part of the HVAC instrument range that we offer. We also have other instruments such as leak detectors for detecting leaks for combustible gases, as well as refrigerants that could come from air conditioning units and heat pumps. So once again, Sauermann certainly specializes in a lot of IAQ applications, but Sauermann does even more than just that. So once again, that's a broad overview of Sauermann as a company. And obviously, we've been working with Total Enviro. They're a very key distributor for us in Indonesia. And we're quite happy to work with Total Enviro, and we are happy to continue our relationship. So the next thing I want to talk about is, once again, before we get into the instruments, talk about the IAQ applications themselves, which is a great thing about the IAQ instruments. Once again, they can be used in many different types of IAQ applications. So I listed very many here. So I just want to mention a few in a little more detail. So once again, people that inspect buildings, whether it's a new build or an existing building, once again, to make sure it's safe and it's fine for the occupants to be in there, with no health or safety concerns. So once again, building inspectors would be a big one for that. Industrial hygienists, once again, to make sure it's a safe environment within the building. A few other applications that get quite unique. For example, greenhouses. In greenhouses, you could have very high levels of CO2, more than what you would normally see in an office building, for example. And then another interesting application that we have a few specific products for would be clean rooms. So when I mention clean rooms, that could often be like a medical or a surgical room. It could also be for semiconductors or other electronics, where once again, having very pure, very good air quality is essential to the purpose of that room. Whether it be medical or more operational or industrial type of application. So once again, in review, this can apply to basically any indoor, and that's a key letter in IAQ. Once again, I is for indoor, any indoor spaces that are occupied by people, especially people where you might congregate, which could be like a hotel, a school, a train station. Those are all examples of where you would want to measure and monitor and keep track of the air quality, in addition to homes and obviously workspaces, also office buildings. So our previous speaker, Mr. Hennefy, already got into a few of the issues about why we care about IAQ and why we should look at that and measure that. But I just want to take an opportunity here to do a little bit of review of that. So once again, we come into contact with many pollutant gases. It could be dust, it could be mold, it could be bacteria. And once again, we need to quantify that, because if there is a high levels of those type of toxins and pollutants, then obviously we need to look at where the source is, make sure you get better ventilation, and minimize the risk from whatever pollutants might be in the air. And once again, it usually comes down to health and safety issues, whether it be respiratory, there could be some carcinogens there. High levels of CO2 can cause drowsiness, for example. So those are all reasons, once again, we should care about IAQ. And as mentioned earlier, not just care about, but actually measure, quantify. So we know, once again, if it's a healthy environment, or maybe if there's a problem, and then you need to, once again, look at the source, get better ventilation, whatever the case may be, to relieve that problem. So once again, as listed here, problems can get worse when you have poor airflow coming in and out for the exchange rate of the air in the building or the room. And obviously, you also care about comfort. So comfort often comes down to parameters such as temperature and humidity, which once again can make it not only more comfortable for the occupants in the building, but also better for their health. Obviously, if it's very low humidity, you can worry about drying out and leading to other health issues. So these are all, once again, all things to consider. And once again, in a lot of cases, improving the ventilation is a quick and simple way to relieve a lot of these issues. However, the other thing to keep in mind also is, obviously with IAQ, we care about health, safety, and comfort, but at the same time, we need to also take into account efficiency and energy use. So there has to be a balance between those two. Obviously, if you have what we call a tighter building, that might mean that you're more energy efficient because you're not, in cold weather climates, you're not wasting the heat from inside the building. And when it's in a very hot environment, if you have air conditioning, you're not wasting that cooler air in the building. So at the same time, you have to balance that. You don't want to be too tight, which means you're very energy efficient, but at the same time, you do it at the expense of bringing fresh air into the building. So once again, that's part of the IAQ point of view is, once again, obviously we care about the air quality, but at the same time, you got to take into account efficiency and energy losses. Okay, so now that we've talked about why, the applications of where we can measure IAQ and be concerned about IAQ and the reasons for that, now we can start looking at, okay, what are some instrument solutions that we can offer to, once again, help quantify a lot of these parameters and use them as a diagnostic tool, once again, to see, perhaps there's a problem. If there's a problem with certain parameters, you can pinpoint where they're better, where they're worse, and hopefully help pinpoint what the solution would be to bring it back to conditions that, once again, are healthier and safer and have better comfort for the occupants within the building. So the first family of products we're going to look at here are the Sauermann IAQ handheld air quality instruments. So we have 3 different models for this. So the first model is the IAQ Comfort. This is the simplest model that we offer in this family. It always includes a gas sensor to measure CO2, which once again is a good indicator if you're having enough fresh air within the building. And then you also have the option to add a CO, a carbon monoxide sensor also. Once again, that's more for health and safety. Now, keep in mind, a lot of people sometimes confuse CO2, carbon dioxide, and CO, carbon monoxide. From a IAQ point of view, they have much different concentrations in a normal, safe, healthy building. For example, CO2 within an occupied space, it's very normal to have levels maybe somewhere from 500 to 700 or maybe 800 ppm. That's normal conditions within an occupied space, nothing to be concerned about. Once you get closer to 1,000 ppm or higher, then it's a little bit more of a concern that maybe you need to bring more fresh air in or somehow have better ventilation in the building or whatever particular room you're in. CO, much different. CO, even at a couple hundred ppm, can actually be lethal within a few hours. So it's a much bigger health risk. So CO in an occupied space, ideally you want to be, you want to have it at no more than a few ppm. So once again, keep in mind, CO2, you're still fine at 5, 6, 7, 800 ppm for the most part in most parts of the world. But CO, completely different. You never want to be more than a few ppm in an ideal situation. So just keep that in mind when talking about those two gases, because that's often can get confused between people when they're talking about both gases. So once again, that's our simplest model, which once again we call the SIAQ comfort. So the next model that once again looks very similar, we call it the SIAQ Pro at Sauermann. In this case, you can have up to 3 gas sensors. So you can see there we list the options of those sensors. So once again, your choices would be CO2, carbon monoxide, CO, oxygen, NO2, NO, SO2, H2S, and CH2O, which is also known as formaldehyde. So once again, these are all gases that you can measure with the SIAQ Pro. So once again, our earlier speaker, Mr. Hanafi, explained some of these gases and why you measure. So just to give you an example, formaldehyde, for example, is a particular type of VOC, which I'll get to in a minute. A lot of VOCs, including formaldehyde, can be carcinogens, cancer-causing agents over longer, obviously over longer exposure times, and also dependent on the concentration levels. Other gases such as NO2, SO2, they can cause other health problems. They can cause respiratory issues and other health problems. That's why they're pollutant gases that people should be concerned about and want to monitor to make sure, once again, you're within safe levels. Or if you're not, obviously that's an indicator. You need to either clear the people out of the building if it's higher enough levels, find a way to bring those levels down with better ventilation and cleaner air, and obviously try to find the source of those. Like, for example, a lot of formaldehyde and other VOCs, those can be found in simple household products such as paint, carpet, cosmetics. There can be a lot of sources for that. Whereas the NOx gases, which is NO, NO2, as well as CO, they're often the byproducts of combustion. So those can be found, on a gas stove within the kitchen, a boiler or a furnace that's heating the building. If it's not being exhausted, the exhaust gases are being exited out of the building properly. Sometimes you have other small engines within a building. Once again, that's why you want to have those vented out to outside the building as best you can and get those gases out of the building. So once again, SIAQ Pro, those are the reason we have those gases that you can measure with that model. And then the third model of the handheld SIAQs, we call the SIAQ VOC, which measures exactly what it says. It measures VOCs, which once again are volatile organic compounds. So once again, that, as I mentioned before, those can be cancer-causing agents. They can cause other health risks. That's why you want to monitor those and hopefully confirm you have the lower levels. As you can see on the screen, we offer a couple different ranges for the VOC sensor. We have a low-range sensor, which measures from 0 to 20 ppm, which is the equivalent of 20,000 ppb. That's typically used for most indoor air applications. We also offer a high range that can measure as high as 200 ppm. That's more for what I would call the more unusual applications, where it be, in a building where maybe you have a paint booth or you have other industrial processes going on where it's more than just a simple office building or residential location. And as you can see there, you can also add other gas sensors to the SIAQ VOC also. Like, for example, you could add the CO2 if you're more worried about general ventilation issues or any of the others. So the nice thing with these models is that you can customize them, and pick and choose exactly what gases you want to measure rather than being forced to choose from just a few different predetermined kits. Now, in addition to the gases, which is the main feature of these models, as you can see below, once again, they can all measure air temperature, relative humidity, barometric, or also known as atmospheric pressure. They all come with real-time data logging software with Bluetooth. So for example, if you're in a certain building and you want to monitor, do a 24-hour monitor because you might be concerned that certain hours of the day, there might be higher risk of having higher levels of some of the pollutant gases. Once again, with the logging software, you can set it up and automatically log data for a day or even longer. And you can set it up, to measure, for example, you save data every 10 minutes, 20 minutes, every hour. You have a lot of flexibility with that. And then another key feature I want to mention with these models is the fact that they have very quick response times. And the reason for that is these models have an internal pump that draws the air into the instrument where the gas sensors are located. So that gives you a very fast response time when you're taking measurements in the field. Like, for example, if you're in a building that might have 15 rooms within that building and you want to measure each room, as you go from room to room, because you have the pump with the fast response time, it typically only takes a minute or two for most of the measurements to stabilize. And then you can save the data if you'd like and move on to the next room. Whereas if you did not have the pump, then you're relying on diffusion. So as you went from room to room, it might take 15, 20 minutes in some cases for those measurements to stabilize when you go from room to room, because you're relying on simple diffusion, not a pump. So the fact that these models have a pump make them superior to, some other types of similar IAQ instruments that are available out in the field. So, and by the way, these three models, the Comfort, the Pro, and the VOC, are all made at the Sauermann factory in the US. Most of the other products we'll talk about today are made in our French factory. So next is the last instrument in the SIAQ family. This one is also made at our United States factory also. This one is called the SIAQ Expert. So this is no longer a handheld like the previous models we talked about, but it's still a portable instrument. It's only about 3 or 4 kg in weight. As you can see, it has the handle that lets you prop it up or hold it. So it's very easy to use, very easy to carry from site to site, wherever you want to make your measurements. So a couple key features for the Expert, why it's our best or most superior model of this family, is, once again, it can have up to 7 gas sensors. So you can see all the gas sensor options listed there, which are all the same gas options that we talked about for the handheld instruments, including the VOC, whether it be a low or a high concentration VOC sensor. And then in addition to what we talked about before, you notice after oxygen, we list O3, which is ozone. So it also has the ability to add an ozone sensor also. So once again, CO2, carbon dioxide, carbon monoxide, VOCs, oxygen, ozone, NO2, NO, SO2, H2S, and formaldehyde are all different gas sensors you can have in this model. And as I mentioned with the handhelds, you have the ability to mix and match and choose those gas sensors however you wish. So once again, you can customize it to meet whatever the requirements are for how it's intended to be used in the field and for whatever type of applications you plan to use the instrument in the field. Once again, as with the handhelds, you can still measure air temperature, relative humidity, and barometric or atmospheric pressure with the SIAQ Expert. It has the same data logging software package. And once again, that can communicate either by Bluetooth wireless communications or a USB cable that comes standard with all the SIAQ models also. And it has, and once again, as with the handhelds, it does have the internal air sampling pump that allows for very fast response times from the instrument. Now, I also want to mention with the SIAQ Expert, there's some other options you can get with it. So I just want to point out a few key ones for that. And once again, these are optional accessories. They're not mandatory, but depending on how it's intended to be used in the field, you might be very interested in some of these options. So the first one is the wireless printer. Once again, if you want to print results and have a hard copy of the measurements you're taking. We also offer a L-type pitot tube that connects to the two pressure ports on the face of the instrument. That allows you to insert the pitot tube into a flue or a duct to measure air flow, air velocity. You can also calculate volumetric airflow once you do that. In the photo you can see here of the IAQ Expert, that's the black hose and probe. Once again, another accessory you can get with it. That would be for if you want to measure air quality from a very precise location. In that case, you attach one end of the hose to the instrument. The other end of the hose is with the stainless steel probe. And then you just position the probe tip to where exactly you want to measure from. Like, for example, that could come in handy if you want to measure from either where the supply or return air is going into a room. If there's like a metal grill or a vent, you can stick it in there. If you want to actually measure the air quality within a flue or a duct, once again, if you have a hole or a way to insert the probe inside, that allows you to measure a very precise location if you choose to. Otherwise, it's fine to use it without the probe. You'll just be measuring the general air within whatever space you're at for the indoor location. So once again, those are a few examples of the accessories that go with the IAQ Expert. But once again, with the base kit of the Expert, you choose the gas sensors you want. So it's a create your own kit. Temperature, humidity, barometric pressure, all included with the base unit. The software with the Bluetooth and USB cable, all included with the base unit of the IAQ Expert. So next, we have another family of products within Sauermann for IAQ. These are still handheld portable instruments for the most part, all portables. Now this, and you see here, I list them they're still under the Chemo brand name. If you remember during the beginning of my presentation, I mentioned that Chemo is a French company acquired by Sauermann several years ago. So some of the older products that are more than a few years old still have the Chemo branding, but it's still, once again, part of the Sauermann family. So this is an example of a few of the Chemo models that can, once again, measure some key IAQ parameters. So in this case, the four models I listed, the first two can measure CO, carbon monoxide. The last two, the AQ110 and the CHT, can measure CO2, carbon dioxide. And once again, with these two, they can all measure the air temperature. And in the case of the CHT, you can also measure relative humidity. Now, these are a little bit simpler than the IAQ handhelds that I talked about before, because these models do not have a built-in pump like the IAQs, and they're meant more for simple spot checking. So they don't have the logging software or the internal pump. That's why they're a little bit simpler than the IAQ handhelds. So continuing with the other handheld portables for IAQ, once again, to review, we have what we call the Class 110, and there's quite a few for this. I'm just on this slide pointing out a few of the more commonly used ones. So once again, as shown on the previous slide, the CO110 that's for a very simple, quick, but accurate CO measurement, while the AQ110, once again, a quick, simple, accurate CO2 measurement. And obviously you can see these two models also measure temperature, but you can see the ranges for the gases are much different. Because once again, if going back to what I mentioned before, CO2, it's not unusual to have anywhere maybe from 500 to 800 or 900 ppm in a room that has good air quality. Whereas once again, CO, you really never want to be near the upper limit of that range of 500. ideally, once again, you want to be single digits or even much closer to 0 for CO. But if you were to have a problem, especially like, for example, if you had a cracked heat exchanger in your combustion heating system within the building, that could, and it's not properly venting outside, once again, that could lead to higher levels of CO. So in those cases, obviously, you want to identify that as quickly as possible and then take the necessary steps to eliminate any health and safety issues. Then the next step up is our Class 210 instruments. So the key one I want to point out here, once again, is our HQ 210. So this one, now we're getting into some other parameters. Now this specializes more as what we call a thermal hygrometer, which is the psychometrics. So here you're measuring air temperature, the temperature within the room or the building, and also obviously the hygrometry, which is the relative humidity. So with these models, and you can see we have a few different kits here. We have the first one listed as a standard kit, once again, where you get measurements for temperature and humidity. Once again, the key here is they're quick and easy measurements, but reliable and accurate. And then we even have some other kits here listed below too. Like for example, here you see the HQ 210P kit. In addition to temperature and humidity, you can also measure CO2. So, and keep in mind, CO2 has become more popular since COVID, because once again, that's a good indication that you're getting enough clean air into the building, you have proper ventilation, you have a quick or a low amount of time needed to replace all of the air within a building, which is called your air exchange rate. So you want to make sure, once again, that you're keeping the air healthy, fresh air, and CO2 is a good indicator, once again, because keep in mind, well, it obviously varies from region to region globally, but typically outdoor air, you might only have a few hundred ppm of CO2. And then it's going to be a little bit higher indoors because obviously you have people breathing and other possible sources. But, as a general rule of thumb, bringing fresh air in helps bring the CO2 down. And then it can also, once again, bring down levels of other possible pollutant gases. So that's part of the reason that you're doing that. So once again, our Class 210 gives you more options of what you can measure beyond some of the gases. So now we're getting, like I said, we're getting into specializing more in temperature and humidity also. So once again, staying within the range of products for the Chemo handheld instruments, the top level model within this family is what we call the AMI 310. And the reason this is within this family of products, it's the superior one, is you can measure many different parameters. You can see here actually up to 6. And once again, you can plug and play with different types of probes. So you can customize even though the instrument looks the same, the base unit, you have different modules that you can plug into it, different probes you can plug into it, all for different types of measurements. And once again, some examples of those probes and parameters that you can use. Once again, pressure, whether it be a static pressure or a differential pressure, the gases, CO, CO2, temperature, humidity, airflow, whether it be with a vane where you're measuring airflow coming out of a vent, or a hot wire where you're measuring airflow within a pipe or a duct. These are all examples of the different types of modules that you can plug in to measure all those different parameters. And besides that, we offer different ranges. Like for example, for measuring pressure, for people that might want a very precise measurement for a low range, we offer a lower range module where, that can measure, a few hundred Pascal, for example. And then we have other pressure modules and pressure probes that can measure for a much wider range of pressure, because once again, it depends on the application. Different applications have different requirements in terms of the measuring range and the measuring accuracy. because as a general rule of thumb, usually if it's a tighter range, it usually has tighter accuracy for those lower levels. So once again, the key here is you have a lot of flexibility and a lot of customizing to make the 310, the AMI 310, measure whatever parameters you want within the selected range that we offer. You'll also see here, notice here too, once again, with it, you get a nice carrying case. There's software available for it. You can also put an SD card inside the unit to save data onto that. So once again, this can be used for longer term monitoring also, as well as shorter, quicker spot checking. So you have a lot of flexibility with this model in terms of how you use it, in terms of the frequency of measurements, as well as the type of measurements and the range of those measurements. So I was just talking about many of the different probes that we offer. So here, once again, I show an example here on the left. You can see we have the AMI 310, and then some of our other class 210 products also can use different probes. Like I listed a few examples here. The MP 210, that's a manometer. The VT, that's for airflow. TM for specializes in temperature. HQ for air quality. But once again, you can mix and match different probes. So like I mentioned, for pressure, you can plug in these black modules here into the back of the instrument. The top one here next to the instruments that has the two metal ports on the side. Once again, that allows you to do differential pressure measurement. You can also do obviously humidity with that. I mentioned before we have the hot wire probes, which once again, at the very tip of those probes, it's exactly as it's named. It's actually a hot wire. As the air passes through it, it cools that hot wire. You correlate that to the airflow. And in the example of the second hot wire probe here, you can see the probe extends out. It's a telescopic probe, so you can change different lengths of it based on the diameter of the duct or the pipe that you're inserting it into for the measurements. I mentioned before the vanes. Once again, the vane is used for airflow coming out of a vent, whether it be typically for the air entering the room. So that's available. I mentioned before, once again, we show temperature and humidity probes. CO and CO2 probes you can get individually also. And then we have some other, I call the extra types of parameters. So once again, we have a tachometer, once again, to measure RPMs for certain equipment. We also offer light sensors because that's part of the comfort issue within buildings that, obviously you need it bright enough that it's safe, but not too bright that it's annoying the vision of the occupants. This other one, we have an omnidirectional, once again, is a different way of measuring airflow. And then cones. We offer the cones as accessories also. They can actually be used with the vane airflow instrument that allows it to adapt to different size of grates and vents for the building. So once again, it just makes the whole instrument more adaptable to different types of buildings, different types of applications. So once again, you notice I keep saying that, we have the flexibility and the customization to allow people to adapt to what their needs are based on what we offer. And obviously on the right side here, once again, you see the L-type pitot tube, which once again, you can stick into a duct or a pipe to measure the airflow within it, and also to calculate the volumetric airflow. So once again, this wraps up this product grouping, which is once again the Chemo branded portable IAQ handheld instruments. Once again, Chemo is part of Sauermann. So if you see the Chemo name, it's part of Sauermann. We're all part of the same company. So So all the instruments I talked about up to this point, once again, have been portable instruments, most of them handhelds. Now I'm going to get into the final product segment that I want to talk about today, which is still IAQ instruments, but now we're getting into what we call the stationary instruments. So this would what we call data loggers and transmitters. Typically, data loggers are very small instruments, small enough that can fit into the palm of your hand. But once again, you're going to mount them somewhere because you want to, just as the name suggests, log data for longer periods of time. Like, for example, if you have a building where you're storing food that can be very sensitive to temperature, something that needs to be refrigerated or something that needs to be within a certain humidity range. Once again, this can allow you to log data. Now, the nice thing with our data loggers, first of all, we do have many different types of data loggers. The one I'm showing you here is our KCC. This is one of our high-end data loggers that can measure CO2, humidity, and temperature, once again, from an indoor application. Now, with all of our data loggers, once again, you can monitor those measurements through the software we offer. So, and for example, if you're worried about temperature, if there's a certain temperature range that you need to stay within because it's whatever, like I said, it could be food, it could be medical equipment or other things that, once again, need to stay within a certain temperature range, you can set up the software to monitor that and then give you alerts and alarms to let you know if you're starting to get out of range. Because obviously, for example, if it's a refrigerated area, maybe somebody left the door open on the refrigerator or the refrigeration system itself is failing. This lets you know and gives you those alarms through the software to let you know there could be a problem. So once again, you obviously can read the measurements on the data loggers themselves, but it's more important because, obviously most people aren't going to be staring at those all day long. So that's why you need a way to log and monitor those values. So like I said, the model I'm showing here is one of our advanced models, the KCC, that can do CO2, humidity, temperature, but we have other ones that do just temperature, just humidity, just CO, just pressure. So once again, we offer our products to be very adaptable to different needs and different applications. So the other segment of, once again, stationary IAQ instruments that we offer are the transmitters that Mr. Hanafi showed during his presentation in one of the slides I noticed. So these, once again, are typically mounted on the wall within a room. So this is when you want to measure, and obviously, once again, this comes with software where you can log data, look for abnormalities in any of the parameters you're measuring. And as with the data loggers, once again, you can have ones that are single parameter units. Like, for example, you might have one that only measures differential pressure. You might have one that only does temperature, one for humidity, one for CO2. All those are examples. Or you can get ones that can measure 2 or 3 parameters. And once again, as you can see in the photos, sometimes you actually have probes that hang below it, and sometimes you don't. Once again, depending on where you're measuring from, and then also depending on which parameters you're measuring. So that's all part of what we offer. Now, I'll give you a few examples of how you can use transmitters in terms of applications. Because once again, okay, why would you need a measurement all the time? Or why would you be looking at specific in a room? So in this example I'm showing here, once again, we're looking at differential pressure because this is tied to airflow. In particular, you might look for differential pressure to make sure there's no obstructions within the duct, to make sure you're getting better air balancing. Along with the differential pressure, you can also measure and calculate the airflow patterns. Once again, for example, you might have a rooftop unit that's providing air conditioning for your building, and you're sending that cooled air perhaps maybe to 10 different rooms within that building. So this is a way, once again, to make sure you're getting good flow to each room, that it's balanced well, that one room won't be very cool and the others will be very hot. So this is just a way you can help monitor that, both, in terms of temperature, in terms of humidity or pressure. Once again, very, very versatile in how it can be used. Here's a very good example of how they can be used, especially for, once again, for differential pressure. And this can be either through a data logger or a transmitter. The reason you want to measure differential pressure in this case is obviously you have a lot of filters within your air handling unit and air handling system, because obviously you want to minimize the dust in the rooms, because that's also can be a health hazard. You don't want to get dust into the human lungs. So once again, that's why we have filters. So a good way to indicate when a filter is starting to get very dirty and might need to be changed out is you look at the differential pressure or the pressure drop across any of the key filters in the system. And once again, you can set it up to give you an alarm where when you have a larger pressure drop, which is an indication the filter is very dirty and needs to be changed, you can get through the software, you can get an alarm or an indication that you have that larger pressure drop and it's time to change the filter. So once again, it all ties back to IAQ. Once again, ensuring that you have a high quality air in the room. Once again, going back to what we talked about throughout the whole webinar so far, which once again is health, safety, and comfort. So once again, this is an example where you can use our stationary devices for that also. And then the last thing I want to mention during my presentation here is clean rooms that I talked about before. These are very specialized applications because these are cases where having very good air quality is of the utmost importance, even more than a normal residential or office location because of what's going on in the room, which, like I mentioned before, it could be a surgical room. It could be other medical or hospital buildings. It could be used in the semiconductor business where, once again, you have to keep the products you're manufacturing very clean, very pure. So in this case, this particular model I'm showing here, our CPE 310, it's actually a flush wall mounted unit where, once again, you can see the differential pressure and you can monitor it. And in this case, the reason measuring differential pressure is very important is you want to keep the pressure within that room greater than outside the room, because you don't want any contaminants coming into the room. So whenever you open the door for people to enter or exit the room, you want the air to move out of the clean room, not into the clean room, because all the air coming into the clean room is already filtered very well. Obviously, that's the supply air coming in from your air conditioning or your heating system. But once again, by measuring and ensuring that you have that differential pressure where the pressure is greater in the clean room as opposed to the outside environment, once again, that helps you keep the contaminants out and keep the superior air quality within that clean room. So once again, we have a couple special models specifically geared for that. And it's very nice that it's flush mounted into the wall. It looks very clean. It looks very professional in terms of fitting into the overall look of the building or the particular room. And as you can see here, sometimes you can have external probes for this. If you want to measure from very exact locations, like for example, right at the door coming in or out of the room. We have the analog and digital outputs coming from this. And as I mentioned before, we have both visual and acoustic alarms that can be tied into the transmitter to let you know, once again, if you might be getting to the point where the pressure outside the room is getting almost the same as what's in the room or possibly even greater, which would be a problem. And in that case, you would have to have the maintenance people come in and and work on the system to ensure that you have the greater pressure within the clean room. So once again, the last family of data loggers and transmitters that I mentioned that once again can do all the other parameters we're talking about in terms of pressure, whether it be static or differential pressure, temperature, humidity, CO2. Once again, they're stationary instruments, but they're still for IAQ applications. They're, similar to our handhelds, but once again, the difference is the handhelds, you can move them around, go from room to room, building to building, whereas the data loggers and the transmitters are stationary instruments meant for longer term monitoring at one location. And that's my presentation. Thank you very much. I appreciate your time.